Okay, on to question 2. We're told a bank is studying the time it takes 6 of its tellers to serve an average customer. Okay, an average customer, that's not the person who, I don't know, got some crazy needs that takes that person a half hour and everybody else in line is cursing and swearing on them. Anyway, 6 of his tellers to serve an average customer. Customers line up in the queue and then go to the next available teller. Data are found in the file called tellers. Okay, state the null and alternate hypothesis to determine whether there is a difference in the time it takes these tellers to serve their customers. So, as usual, this is going to be that the means are all equal. You can say means are all equal, but strictly speaking, we should say mean of teller 1 equals mean of teller 2, etc., etc. I'll fill that in later. Versus at least one is different. Okay, now we are asked to run the appropriate test in Minitab. We are comparing 6 different tellers. We're looking to see whether their averages are different. That means this is a ANOVA situation. Alright, I've got the data opened up here somewhere. Let's have a look. So we've got the time it takes to serve the customer in seconds. Don't know if I believe half of that. And the tellers are here 1, 2, 6. Alright, and there's a whole boatload of them. Alright, we go to Stat ANOVA. This is a one-factor analysis of variance. All our data are in one column. The thing we've measured, which is the response, is time, and we want to break it out by teller. As usual, we want box plots of the data, turn off the interval plot, and we want the 4 in 1. Just in case, we may want the residuals, so get Minitab to store them in case we got to check them for normality. Say OK and OK. Now let me pull that away for a moment and let's have a look at the box plots. Now, question to ourselves is, does it look like there's any real difference in the serving time of these tellers? And to be honest, their means, which are here, these circles, are pretty much the same. Teller number 1 looks a little bit different from the rest, but I'm not seeing too much here. The other question is going to be whether my data are normal in all the groups, and that group looks normal, as does that one. This one looks a little bit skewed. This one has an outlier, so that could be an issue. And that one looked mostly normal, and this one looks mostly normal. Oops, so I got another outlier down here. So I got 2 groups that have outliers. That might have significance for my conclusions. Alright, I'm going to shrink that down. Oh, and by the way, we also need to know whether the variability in the groups is roughly the same. These 2 look more or less to be the same, but this one seems more, well, no, let's see now. Overall, that one is about the same variability as this one. This one's a bit smaller. 2 of these look longer than the rest, but that may or may not be significant. Let's look at our residual plots. This looks fairly normal. The points are all falling along a straight line. My decision is going to be that my residuals are normal. This plot is supposed to tell me whether the spread in the groups is about the same. Now this vertical spread is fairly similar to these others. Yeah, some of them are a little bit longer than some of the others, but by and large, I'm not seeing huge differences here. I would tend to conclude that the variance is equal, and the box plots more or less told us that too. So we may have met the assumptions of the ANOVA, and let's scroll up and let's pull these data, this information in to our Word document and see what we're going to say about all this. Alright, so right here we were asked to run appropriate test in Minitab and show the output. Oops, except I don't want to have all that turned on. Okay, so here's my output. All means are equal, yada yada yada. Now, here's what we're interested in. And really all I'm interested in is that p-value. And that p-value is 0.191. So, is there a significant difference? I'm going to come down here, by the way, first of all. What are your conclusions for the test? Well, I'm going to kind of skip over things here. My p-value equals 0.151. I need to make my conclusion at a 5% level of significance. Is my p-value less than 0.05? Answer is going to be no, because 0.151 is bigger. In which case, we fail to reject the HO statement, and we are going to conclude that there is no significant difference in the average serving time of these 6 tellers. Okay, then we're asked down here, is it appropriate to run the follow-up Tukey's? And the answer is going to be no, because ANOVA says or declares there is no difference in the tellers. So don't go looking for trouble. All right, now up above here, okay, that was question A, B, question C. What are the assumptions? Well, all right, the assumptions are the same as what I had here before, so I'm going to copy and paste them. All right. Now, the independence and the randomization, I don't have a clue. There's nothing told in the question. Really, presumably, you'd have to have time these tellers, I don't know, randomly at different times of the day, and the tellers themselves would have had to been picked randomly and independently from all the tellers. We're not told any of that information, so we really don't have a clue about this one. Is it met? I can't say no. I don't know whether or not this one is met. Okay, data in each group are normal and the box plots show equal variance. Well, let's go back to our Minitab. What did Minitab tell me? Let's get back our plots again. Where am I? Box plots. Box plots are mostly normal, but I have 2 groups that have outliers. That may be an issue for these data. So, coming back in here to my Word file. Hang on here now. Box plot. Okay, so first of all, I have 2 groups with outliers. That's a problem. All right, and box plots show equal variance. The equal variance is a maybe. They don't look too bad, actually. That's really the question you're asking yourself, because it's very difficult to determine whether they're equal or not. What you're really asking yourself is, do they look like they're really different from each other? And I don't think they do. The overall spreads are more or less the same. Now, my residuals are supposed to be normal. Yep, my normal probability plot said that. And my residuals show equal variance. Yeah, I'd have to say the spread in that resids versus fits plot looked pretty good. All right, so we're asked to confirm whether each of these assumptions is met with the appropriate plot. So what I would expect you to do is bring those plots into your assignment or whatever and make a comment on those plots. So we're pretty well finished with this one. I'll finish this off with all the plots and post that.